Hi everyone, this is the video recording that's going to help you do the homework A of week 4 distance learning. It's on distance formula. It should be a review because we have covered it before the school closure, but I am going to walk you through it just to recall what we learned many weeks ago. So to begin, I am going to go through what you're expected to do. This is a 2-sheet worksheet. 2-page worksheet. This is the first page. It goes 6 problems there, and there are 6 problems on the second page. On the last page of the link, you will find the answers. Okay, the answers are there not for you to copy the answers, but for you to check your answers to make sure that what you have is correct, what you're doing is correct. So that is really important. So make sure you go through the answers and check it off at the end with a red pen to make sure that you're doing things correctly. If any of the problems you did not get correct, see if you can rework that. Do it in red pen so that I can see that you actually try to rework it and see if you can come up with the right answer. Okay, I am not grading for correctness. If I see a lot of red marks because you did not do it correctly, however you tried to redo it and got the right answer, you're going to get full credit for it. So make sure that you do that. So let's get started. I am going to start with the first problem. Okay, what does it mean to find the distance between each pair of points using Pythagorean theorem? So you're given 2 points, 1 point here, 1 point here. We are trying to find how long is this length. Okay, and it says to round your answer to the nearest tenth if needed. So let's just do that. How do we find this distance? Well, it's a Pythagorean theorem, isn't it? So look at this. If I am thinking about this triangle, okay, can't see it very well. Let me use a different color. Okay, this is a right angle triangle. Okay, if we know how tall this triangle is and how wide this triangle is, can we figure out the hypotenuse? Yes, we do. We know how to do this by Pythagorean theorem. So remember, Pythagorean theorem says a squared, when you're given a right angle triangle, if this is A, B, and C, Pythagorean theorem says a squared plus b squared is c squared. So that means if I square the length of the height of the triangle and add that to square of the base of the triangle, that answer is going to be square of the hypotenuse. So we're going to use that. What do we know about the height? Well, we can count the squares. 1, 2, 3. We know that this is going to be what we are going to be calling A, which is 3. And this, how wide is the triangle? 1, 2, 3, 4, 5. B is 5 units long. So if that is the case, then to find this C, or let's call that distance, because that's what we are trying to find. Okay, so we're going to say that A is 3 squared, B is 5 squared, is equal to C, in this case, is distance squared. We're not calling it C, we're calling it distance squared. This simplifies to 3 squared is 9 plus 25 is equal to D squared. Remember, 3 squared is not 6. It's not 3 times 6, 2. It's 3 being multiplied to itself 2 times. So it's 3 times 3, which is 9. This is not 5 times 2, which is 10. It is 5 being multiplied to itself twice. So 5 times 5 is 25. 9 plus 25 is 34. So I am going to rewrite this as D squared is equal to 34. I just like to bring the variable to the front because that's just always easier for me. Okay, so D squared is 34. So how do we find what D is? We're going to take a square root of both sides. Then you are left with D is equal to square root of 34. Now, It says to round your answer to the nearest tenth if needed. What does that mean? That means that if this is a perfect square, then we want it in integer. But is this a perfect square? 34 is perfect squares are numbers like 1, because 1 squared is 1, 2 squared is 4, so 4 is a perfect square, 3 squared is 9, 9 is a perfect square, and 16 is a perfect square, and 25 is a perfect square, and so on. So this is not a perfect square, so I need to use my calculator. And remember, when you're using calculator, the square root function, they look a little bit different for each of the calculator. If you're using your phone calculator, it's going to be different. So if I turn it on, if I just put in 34 and find my square root sign, and it's right here, and this is not the main button, so I need the second function. If I do this, you can see that 34 did not go inside the square root. So this calculator, I need to do the function first. So I'm going to clear there, and I'm going to do second square root. I want the square root sign, and then 34, and then enter, and I get 5.83095, so on. So I will write that down, 5.83095 ... Okay, all right. But now we're told to round your answer to the nearest tenth. Where is the nearest tenth? Look at the digit. This is the ones digit, this is the 10th digit, this is the 100th digit, 1000th digit, so on. So that means we want it to the 10th digit, so we want to cut off here, cut off the number here. But before we cut it off, we need to have a look at the next digit. Look at the 3. Is this greater than 5? If it's 5 or more, 5 or bigger, then we need to add 1 to the previous number. It becomes 5.9. However, this is 3. That means it's less than 5. So we don't have to do anything. We just need to cut it off. And therefore, the answer becomes, distance is approximately, this is the curly bracket equal sign. It means approximately 5.8 to the nearest 1 decimal place. So that's the first problem. Okay. All right. So it's very similar. I am going to go to number 4. So actually, you are going to do number 2 and number 3 as part of your homework. Follow the similar process. Now let's do number 4. Number 4 is similar, except we want to get the answer in exact radical answer. So we want the answer to be exact radical answer. What does that mean? Well, let's go through the problem first. Just like before, to find this distance, we know that it's going to be this height squared plus base squared, because it's a right angled triangle. So how tall is the height? If I count 1, 2, 3, 4, 5, 6, that's going to be 6 squared. And how tall is the base? 1, 2, 3, 4, 5, 6. That's going to be also 6 squared as well. And is equal to d squared. So 6 squared is 36 plus 36 is equal to d squared. So d squared is 36 plus 36 is 72. Okay, and to find what d is, I am going to take a square root of both sides, like that. And this leaves me with d is square root of 72. Okay, so this will be the exact answer. However, we do not leave it like this. We try to simplify radicals whenever possible. Sometimes this number cannot be simplified further. However, sometimes you can. So remember, for the perfect squares were numbers like 1, because 1 squared was, so perfect squares were numbers like number 1, what's 2 squared? 4, what's 3 squared? 9, 16, 25, that was 5 squared, what's 6 squared? 36, 7 squared is 49, and so on. Okay, so we need to see, can I divide this 72 by any of these numbers? Okay, If you say, oh yeah, I can divide this by 36 here, okay? If you didn't see that, maybe you just said, I think it's divisible by 4. Let's see if that works, okay? That is, so this is same as 72 is same as square root of 4 times square root of 4 times what? 4 times 4, 72 divided by 4 turns out to be 18, okay? Then this means this is same as square root of 4 times square root of 18. Okay, now let's look at square root of 18. Is that divisible by any of these other numbers? Yes, I see the 9 here. So then I can say, okay, square root of 4 times, instead of leaving it as 18, I can say this is same as 9 times square root of 2. Okay. Now let's simplify. What's square root of 4? That's 2. What's square root of 9? There is a multiply sign here. Is 3. And then, can I do anything with square root of 2? No, I cannot. So you're left with that. And 2 times 3 is 6 root 2. So distance is 6 root 2 is my answer. Okay? Great. Now comes to the question. Now, do we always have to draw these points in order for us to be able to find the distance? Well, I hope not, because sometimes the numbers are going to be huge and sometimes the numbers are going to be decimals and it's going to be a lot more complicated like that. So I want us to come up with the formula that's going to help us. So, and we've done this before. So let's think about the distance formula. So distance, what we're doing is we're actually using a squared plus b squared is c squared. So from a squared plus b squared is equal to c squared, I can come up with, all right, what is a squared? A squared is how much did the y value change? Okay, how much did the y value change? So how much did the y value change? Or we can call it change in y. That's how much did the y value change, all squared, plus how much the b is how much did the x value, x coordinate change. So that's going to be x, change in x squared is equal to distance squared. Okay. Now from here, we can take a square root of both sides to find what d is equal to. And this equation becomes d is equal to, what is change in y? Actually, I am going to start with change in x first. Well, no, it doesn't really matter. Change in y is how, if I have this point as x1, y1, and this is x2, y2. If I call this point 1, point 2, then distance is y1 or y2 minus y1 whole squared plus, what's x change in x squared? That's x2 minus x1 all squared. And there's a square root sign. Okay, so this is my distance formula. So let's use that to figure it out. Okay, I am going to stop the video now and we're going to continue in the next video.